Assalamualaikum, salam sejahtera. Okay, so today we make again to cover on chapter 5, which on topic magnetic circuits. Okay, so in this topic, so we will cover several subtopics which related to magnetic circuits. Okay, so you can see here. Okay, the first is the nature of magnetic fields. Okay, about the electron magnetisms, flux and flux density, magnetic circuits, air-gap regions and illuminated cords, series and parallel elements, magnetic circuit with DC excitation, magnetic field intensity and magnetization curves, about the Ampere circuits law, series magnetic circuits, which given flux and you have to find the Ni. On the series parallel magnetic circuits, which the series magnetic circuits will give with a given Ni, and you have to find flux. On the properties of the magnetic materials, magnetizing a specimen, hysteresis, demagnetizing process, and also the magnetic fields measurements. So we will see later on, one by one, about the subtopics of this chapter 3. Okay, so the first subtopic is about the nature of the magnetic fields. Magnetism refers to the force that acts between the magnetic and magnetic materials. So the region where the force is felt and existed is called the magnetic fields. So Faraday flux concept helps us visualize these fields. Magnetic field can be shown in a line in space, flux line, or line of force. If you see here, the flux line is the lines in lines in the space, as what illustrated in this figure. So this is the north poles and this is the south poles. So this region, where the force is felt and existed is called the magnetic field. These force regions. So the symbol of the magnetic flux, is P. So the phase is stronger. The field is strongest at the poles. So we have two poles here, which are north poles and south poles. And then the flux, in between, these poles, the line of flux in between these poles, where the field is strongest at the poles. Direction of the flux line is from north to south externally. So the direction, if you see here, the arrow of the flux is come from the north poles to the south poles. On the end to the S. And then the flux line never cross. They have the beautiful flux without intersects each other. So the flux line never cross. Okay, what is the characteristics lines of the flux? So the direction of a line of the magnetic flux at any point is a non-magnetic medium such as air, is that of the north-seeking poles of the compass, needles placed at the point. So the direction, the direction of the line magnetic field at any point of the non-medium, is what is illustrated here. The non-magnetic medium can be air, wooden, or the non means the non-magnetic medium. The non-magnetic medium is the one that can be attracted with the magnet. So each line of the magnetic flux form a closed loop. So if you see here, the flux for each of the line of the flux form a closed loop. From north to south. So line of the magnetic flux never intersects. So this is some characteristic of the line of the magnetic flux. It's never, okay, they never intersect each other. So the flux line of the opposite of the pole attract at one another. Okay, if you if you put two two magnet here, which the north and the south is placed at the first for the first magnets, and the next magnets is placed from north to south in series. There are these two magnets are put in series. Where your south and north of the first and the second are nearer to each other. So you can see here the opposite of this south and north poles will attract the flux of this opposite direction will attract one another. However, for the flux of the same poles repel one another. If you put the poles the same poles from two different magnets from two different magnets, you can see the flux we repel each other. What is the ferromagnetic materials? Just now we see on the non-magnetic materials and the flux exists in the non-magnetic materials. The ferromagnetic materials. The magnetic materials, which materials that attracted by magnets such as iron, nickel, cobalt, and their alloys are called the ferromagnetic materials. So the non-magnetic materials such as plastic, wood, and glass. So for the plastic, wood, and glass, which is a non-magnetic materials, is provide the easy path for the magnetic flux. If you see here, the flux can easily go through the plastic or the non-magnetic material as compared with the ferro magnetic materials. Electromagnetisms. So generally two types of magnets. We can classify magnet into two types, which are electromagnet and also permanent magnets. So this is the basic principles. When we have a road, and we have the current through the road. So the magnetic field produced by the currents, magnetic field produced by the current, which the field is proportional to the if you see, you can get the right hand rule to see the direction of the current and also the direction of the flux. So this is the direction of current is given by the direction of your thumbs here. And all the four fingers we give you the direction of the flux. Current creates a magnetic field that concentrates about the conductor, uniform along its length, strength which is directly proportional to the R. So to determine, as I said, the direction is by using the right hand rules. So follow the direction of I, as what your is what given by your thumbs. And the other four fingers give you the direction of your magnetic fields. So if the conductor is run into a coil, so the field of each individual turns combine and producing a resultant fields. So if you have this conductor, one conductor, you want with the coils, on the conductors, and then the field of its individual turns combine, the field, you have many fields here and producing the resultant fields. You have many flux, or you have many flux to build up the resultant fields. So if the coil is wound on the ferromagnetic coil, almost all flux is confined to the core. Although a small amount called stray of the leakage flux passes through the surrounding air. So if you have one core, one here is the iron core, and then you wound with the coil of one of the legs of the core. Okay, so we can consider, okay, almost all the flux confined into a core, okay, and only a small amount, okay, that call the leakage of flux, okay, or stray, okay, will go to the surrounding of to the surrounding air. Okay, so now that the ferromagnetic materials, okay, is present, so the core flux is not longer directly proportional to the current. Okay, so how to determine the poles? Okay, okay, if you see here, okay, from this side, from the upper side, okay, so you can see, okay, the direction, okay, here, okay, the direction, okay, the arrow is down at this side, right? And then it will go down again to, okay, so it will go up, okay, on this side. So we can consider, okay, this as a north, okay, which give you, okay, the anti-clockwise, sorry, okay, the anti-clockwise, okay, north. So the direction of the anti-clockwise flux line give you a north pole. While, okay, at the bottom, okay, okay, the direction of the flux, okay, views from this side, okay, you have, okay, this side is turn, the arrow is turned this way, and then, okay, the arrow, okay, on this side is turned to upway, okay, which give you, okay, the south poles, okay, and the direction is clockwise, okay. All right, so then I stop here, and then, okay, we will proceed, okay, to we will proceed to part B. Okay, so thank you for now.